All right, we are now recording. So yeah, let's go to Bochan. You want to give an introduction?
Yeah, hi everyone. My name is Fortune. I'm the co-organizer of this meetup. I'm in Vancouver, BC. I work for a company called Skills. It's a gaming platform, and we are using Rust in some very like high performance cases. So I will share that next month. So personally, I used Rust for about 2 years for now, and this is actually the second project that we use that in production. So yeah, very glad to meet everyone here.
Cool. We'll go to Christopher.
Hello, everyone. I'm Christopher Sebastian. I'm from Arizona. I saw the announcement in the Arizona Rust developer group, and for this meeting, so I joined just to meet everybody. So hello, and I work at a semiconductor related company called Deca Technologies, and we use a lot of Rust for high performance stuff. Yep. That's a summary.
All right, Alex Cheadle.
Hey, so new to Vancouver, just over here, working for Amazon. Kind of curious about Rust, just doing a bit of hobbyist projects, but not using it professional. So thanks so much for organizing the talk today.
Yeah, no problem. Let's go to Eric Yen.
Hi everyone. So my name is Eric. I work for a company called Object Research Systems. We basically develop an imaging analysis platform. We use a lot of C++, but I'm really curious about Rust. I don't really use it. I've kind of started reading through the Rust book, but I'm just curious about learning about Rust and maybe potentially using it in our work.
Awesome. Yeah, we'd like to see more Rust in production.
For sure, me too.
Let's go to Dylan Jones.
Hi, I'm Dylan. I don't use Rust professionally. I'm just curious about it. I was invited to watch this by Jesus.
Oh, okay.
Your audio cut out a little bit.
Yeah, sorry about that.
Yeah, no worries.
That's it.
Can we go to Claire? Claire Wang?
Want to introduce yourself?
Yeah, we're currently just doing a round of introductions.
It's just a quick intro. Okay.
We can also skip. That's fine. Oh, okay, in the chat. All right, welcome. Student? Is that your name?
Hello, can you hear me?
Oh, we can hear you.
Oh,
yes.
Nice.
Hello, Evgeny.
Hello, everybody. I'm Evgeny. I live in Richmond, BC. I work as a C# programmer. And Rust. My hobby is Rust. Learning Rust and solving problems in Rust on Xcode and other platforms. Thanks.
Yeah, always good to see you. We'll go to Sunil, and I think we'll just jump into the presentation after that.
Hey, hi everyone. I'm Sunil, and I'm new to Vancouver as well. And I got to know about this Rust event when I was just browsing through the Meetups app. I work for a banking company here called HSBC. So I'm a senior software engineer now. and I'm just like interested in like knowing more about Rust. Like I've never used it before, but like this is my first time I'm getting to know it.
Cool. Yeah, welcome aboard.
Thanks.
All right, Jesus, do you want to share your screen and start the presentation?
Sure. So if people need to like pause or talk to me, just speak out loud because I won't be actively monitoring the comments section. Okay.
Yeah, I'll monitor the comments and I'll stop you and let you
Okay.
know if there are any questions.
Awesome. Okay. Okay. Can you guys see this? Good. Okay.
Yes, we can see it, but I just want to mention that your microphone is not super clear. So maybe just speak a little louder and then we can hear you better.
Oh, okay. Does this sound better?
Yeah.
2, 3. Okay, awesome. Okay, guys, welcome to Considering Rust. My name is Jesus Guzman Jr., and I have unabashedly stolen the title of this talk from another talk given by John Jangset, a very prominent member of the Rust community. He gave a more general talk regarding Rust last year, and this talk is with a focus on Java and Rust. So comparing both languages and seeing how they fare out for backend web developers. So a little bit about me. I am a software developer. I've been working for around 4 years professionally. I have been working at my current company, Choice Hotels International, for around a year and a half. And probably the most interesting thing is that I've been learning Java and Rust at the same time simultaneously. So I sort of have this like kind of like maybe not wall thought out, but I have like this learning experience that is like stepwise with each other. So I'm learning Actix Web and Spring Boot and learning the differences between both frameworks. And I'll be showcasing those two today in this talk. So a little bit about philosophy, like why are we here? Why are we gathered? So my thinking is this, like humans make mistakes. As software developers, we have all these like tasks or processes that we use to mitigate potential mistakes that can, for example, lead to like production outages, that can lead to loss of revenue, loss of life. And we have all these tools that we use, like we use pull requests, we do peer reviews, unit tests, integration tests, things like that. We have blue-green deploys, canary deployment, a QA process, all these things. So if I were to tell you, hey, you have all these tools, but there's another one, and it is free and open source, it is easy to use, and it is, say, highly efficient, as in it gives like no false positives. Like, wouldn't you like be interested in learning more about it? And I think that tool, at least I want to assert that that tool is the Rust compiler because it can catch mistakes literally as you type them in your keyboard. So it's basically having like a second pair of eyes next to you and telling you what mistakes you're making as you're typing them. So to talk a bit about Rust, let's put it in the context of Java. So let's talk, just briefly discuss Java. So Java came to the world in around 1995 produced by Sun Microsystems by a guy named James Gosling. If you were to like see an imaginary billboard of Java, I think the word you would see is Wara. The write once, run anywhere. The big selling point of Java was you write your code once and you deploy it to all these different devices that run the Java runtime environment. So these devices can be computers, TVs, VCRs, like servers, all what have you. All these different things can all run Java because Java is portable in that way. So the way Java achieves this portability is it compiles to a bytecode. And I'll talk more about bytecode and how Java uses bytecode where Rust compiles all the way down to machine code. So Java meet Rust. So Rust is famous for a lot of things. Probably the most prominent characteristic of Rust, one of its key buzzwords, is no databases. And I'll be discussing those right now. So a database, in case you guys don't know exactly, it is defined as multiple threads accessing a memory location. And one thread, or at least one thread, wants to write to that memory location. So in safe Rust, you won't have any databases because Rust will prohibit that. The semantics of the language will prohibit aliasing mutable references. So aliasing means like multiple threads accessing the same location memory. So this is Rust's major selling point. If you look at Java, for example, it's the burden is on you as a programmer when you're doing like concurrent programming to check if you're gonna have a database, you need to introduce synchronization. If you don't, you will invoke undefined behavior. So for people who don't use Rust, you run things like thread analyzers. For Go, for example, the official recommendation for Go is to run a production server with Go with basically a special subsystem that analyzes memory access and tells you if there is a database in your memory in your program. So with Go, with Java, you need to employ a special process to rule out or to at least know that you didn't have a database. With Rust, you got rid of them at compile step. And I'll talk a little bit more about compilation in the following slides. But let's look at an example of a database and compare it to a race condition. So let's not confuse both. So a race condition is not the same. A race condition is a more general phrase for anything for basically any sort of like indeterminate behavior that is caused by operation ordering. So think of it this way, like your CPU has like hardware interrupts that will stop the current process or thread and like alert some other thread that, hey, the network socket received some bytes. So things like that are basically like race conditions. And the world is full of race conditions. Like you don't eliminate them. So there's no claim that Rust eliminates race conditions, only data races. Okay. So let's look at an example of a piece of code. Sorry, this one here. This is a very theoretical, dumb piece of code. This is like, think of it as an ATM runs this code whenever you want to like transfer money from one account to another. Here we have a data race and a race condition. So the data race here, for example, so when multiple threads are accessing the balance, they might read different balance amounts. So that's the data race. And the race condition is what's going to lead to the creation or the loss of money. So a very naive way to fix this really dumb piece of code is here. You basically introduce atomics. Atomics can be implemented by the runtime through a mutual exclusion lock or through disabling interrupts, for example. Here we have no data race, we got rid of them, but we still have this key invariant of like not losing or creating money can still happen because you have different atomics, whereas you should instead have this. Here we have the whole operation wrapped in an atomic. It either completes successfully, the money is transferred, or it doesn't complete at all. So here we have no data races or race conditions. So with Rust, the major selling point number one is no data races. The second selling point is zero cost abstractions. And that is brought to you by the compiler, like the compilation differences. So let's take a look at compilation in Rust. So comparing it to Java, remember I said Java compiles to bytecode, which is portable, which will run anywhere you have a Java runtime environment, where the JRE loads the classes that interprets the bytecode. It will make the system calls and run the code that you set out to craft. With Rust, when you compile the code, you compile it all the way down to machine code. You have these different steps in the compilation process. The HIR is the high level intermediate representation, and then it goes into a mid-level intermediate representation, at which point you have LLVM intermediate representation. That's sort of the step in the compilation where Rust ceases to exist, and then you have the LLVM toolchain actually creating the machine code for the different architectures that you want to compile to. So because this process is so intertwined, like there's so much you can do with it, you're able to do a lot of analysis on the very early on in the early stages of the compilation process when you have the Rust source. And this enables you to have something known as zero cost abstractions. It's not unique to Rust, by the way. C++ hasn't, for example. But an example of a Rust zero cost abstraction is an iterator. So if you have an iterator, if you're doing like functional style programming and in Rust, and you compile this iterator, the compiler will analyze it and will break it down, desugar it into basically like a loop or a for loop. With Java, an abstraction, it will not be zero cost. They will have a penalty. So think of another abstraction in Java, for example, an interface. So in Java, you can create an interface, which is a way to like define some sort of like contract, and something that implements that interface meets that contract. So with Java, these like having an interface, implementing it, that comes at a cost during runtime. So when your code is live, you get a performance penalty because you're using these abstractions that don't vanish, unlike the ones we see in Rust or in C++. So these castles in the air, like abstractions that we as developers use to reason about our code, they can mostly disappear with Rust, and that enables like really high performance, while also giving you the sense that you are, using a really nice language that gets you everything you really need or want. You're not working with assembly code. It is not that level. You feel like you're writing Java or Python or something else. You feel like you're writing something high level. And then I'm going to show you guys. So in this talk, we're going to show some actual code to kind of like see the feel of Rust if you've never. I mean, hopefully you guys have used it, but I'm not sure. So we'll talking about that. But before that, let's talk about another keyword, another buzzword for Rust, and that is the borrow checker, or better said, the ownership rules and the borrowing rules of Rust. So look at this really crude example that I made. So on the left is Rust. We have a struct, it's a turtle, and we create two instances, a Tootle and Galapagos on line 7 and 12. So when the function ends on line 16, we have to destroy these instances, these structs, and clean up. So on the right is the mid-level intermediate representation. So think of it like midway through compilation. This is what Rust is saying. So as you're typing the stuff on the left, Rust is like VS Code, Rust Analyzer, whatever you have, is literally generating the code on the right and inserting at the appropriate locations the calls to free memory. So on lines 19 and 20 on the right, you see the reverse order. So you're deleting the second item and then the first item in reverse order. This is something that if you were a C programmer, you have to do manually. If you're a C++ programmer, you might have to do depending on other items, other elements. In Java, you don't do this either. You don't have to delete and free your objects because in Java, you have the garbage collector. So let me talk a little bit about the garbage collector. So in Java, when you do a new, you're asking the heap allocator to allocate some memory on the heap for this new object. And you keep doing that in when your program is running in production and just during runtime you create new objects, the heap allocator dutifully hands out the references to the space in the heap. And at some point, the heap allocator starts to like get really nervous. It's like, oh my gosh, I'm running out of space. And it calls the garbage collector. The tracing garbage collector then gets invoked. It stops your program. It goes through every single reference. It basically follows pointers and pointers and pointers and builds a little map of pointers. And anything in between that is not connected, it says, hey, heap allocator, that's free space. Use it. And then the garbage collector recedes into the background, and the heap allocator is able to hand out more memory. So remember, all of this is a tracing garbage collector happening while your program is running, like in production. Like if you think of it scaled out horizontally, bunches of servers are having this stop the world, analyze what is being used, say what is not, and then continue. All of this happens at runtime in Java. And in Rust, as you type as a developer, the computer inserts the appropriate like memory-free calls, as we see here on lines 19 and 20, the storage, dead, and the near. So this is amazing. This is literally like something really cool that only Rust, or Rust is like the only mainstream programming language I can do this, and a little bit of C++. So let's look at this example. So this is a new slide in case you guys didn't see that. So here we have basically the same tortoise struct, but we have a new scope being introduced on line 8 and line 13. If you look at the curly brackets, it introduces like a new scope in programming or in Rust as well. So we see that Tootle, the first tortoise, lives inside the scope. You can think of it as its home. And once the scope ends on line 13, we free the turtle. Like we free the memory of Tootle, which corresponds to, if you follow the arrow over here on line 16. So again, this is just an example of showing you guys the analysis happening as you're typing your code, inserting the appropriate deletions. This is all going to happen, yeah, during like development time. So okay, cool. So we talked about the buzzwords in Rust. We talked about on this example, it's like no garbage collector. We talked about the zero cost abstractions. So now let's jump a little bit into the code that I wrote for this talk for you guys to see. It's kind of like a comparison of a web service that is written with Actix Web and in Spring Boot. It's the exact same code. It's the exact same business logic implemented twice, okay? So on the left is like the specs, I guess, for Java and then for Rust. If you're new to one or the other languages, you can kind of see like the equivalents. So Maven MVN is our like dependency management system for Java. There's other ones like Apache, like Ant and Gradle. When you install Rust, you get Cargo. It's kind of like all built together. Cargo is a dependency management, and it's really great. It works just like npm. So let's jump into the code. So this you will see if you clone the repo. You will see the stack comparison is right here. I added some useful links if you want to learn more about, for example, the Tokyo runtime that I am using. If you want to learn more about, I guess, OpenJDK, maybe you want to learn more about Spring Boot. Whatever you don't know, whatever's unclear, you guys can click on the links, and I'll post a link to the repo further down. But this is the README. And before we even like look at this code, the business logic that it is running is super simple, fantastically simple. It is a web service that takes in, that communicates via HTTP requests. It will take a payload to create a user account. It will take the password, generate a salt, hash that password, put it in the database, and respond with a payload that contains the initial fields plus a few other fields and the hashed password. That's all it does. Nothing fancy. It's literally one request. It's just implemented twice. So take a look here. So on the left is our handy dandy, if you're familiar, our Pom files. So Pom files are what you use to define dependencies and a bunch of other stuff in our Java Spring Boot application. On the right, we have a cargo.toml. This is your dependency manifest, stating what dependencies your application uses, which ones it uses during build time, and some package information here. So maybe it's not super obvious, but if you take a look, there's a lot of dependencies on the right that we don't use on the left. So if you scroll down, this is just build information. These are all the dependencies. They're mostly Spring Boot, Spring Framework dependencies. And this is like the first biggest difference is Spring contains everything under the kitchen sink. You don't need much else besides some Postgre and some password hashing utilities. With Actix Web, it's more like a micro framework. Think of it like Flask. If you've ever used Python, you have to include other dependencies like Argon2 to hash your password, or rand core to generate random numbers, things like that. So that's the first big difference if you are developing in both. Let's jump into main. So another ecosystem difference here is that Spring, it requires like a web server, a Java web server, which is Tomcat. So the Pom file that we just saw here has like a parent Pom file, and that creates, it has like these goals basically that tell it, hey, when you run this Maven command, spin up a web server and run my application, my Spring Boot application on this server. So all that is sort of like done for you. So this is why you don't see much here. Whereas in contrast with Actix Web, our server is literally on line 33. The application it's going to run is on line 34. So when you run main, you run some setup code, and then you initialize your server. So this you have to code yourself. So these are kind of like ecosystem differences, not a big deal. So next up is error handling. This is a bit complex, so we're not going to get too much into it. Don't even look at this, actually. We'll discuss these later if we have time. So, okay, the big juicy stuff. So remember, this is a business application. It needs to be able to represent a user account internally in the system, and we do that by defining the class account or the struct account in Rust. So very simple, like this is very standard Java. You have your getters and setters down here. And up here you have a status, because an account can be in good or bad standing. So nothing fancy. Here in Rust, it's a bit more filled out because I'm using what is like custom types. So using the new type pattern. So if you look at these lines down here, like ID is defined as wraps a UUID. A username wraps a string. So this is the new type pattern in Rust. I'm using it so the types in account aren't UUID, aren't just strings, aren't just arrays of bytes. They're in fact my own defined custom types. So the new type pattern has a lot of advantages. The primary advantage is you don't make mistakes. So I don't know how many of you guys have ever made a mistake in Java where you're mapping from A to B and like you mix up. If you don't have a good IDE, for example, you might like mix up the mapping because they both are the same type. They're both strings, for example. So with using the new type pattern, you don't have those issues because it's a different type. And probably the most important thing is these types will compile away. So this is a zero cost abstraction. It won't really be represented as a username. In fact, it'll just be like a string. So that's one of the differences, I would say, is you want to use a new type pattern in Rust because it vanishes when you compile, and it catches mistakes when you are mapping. So the next thing we want to talk about is the payload for creating a user. So the HTTP request requires a payload with a username, email, and a password. And we run some validation on this. So in Java land, we're doing like the standard validation, adding these annotations here for size, validating that the email is properly formed, is that the password is not blank, yada yada. So in Rust land, we need to instead dip into the world of free and open source, bring in an external dependency, a crate called validator, bring in the validate trait, derive some methods with this derive attribute, and then we have the same. We have exact same business logic, the error messages, and the same constraints that we see on the left. So nothing too difficult. It's exactly the same thing. So this is the payload when you create an account. When you send a request to our server. Up next is, remember, we have to talk to the database. So we have to transform this request into something the database will understand. So for those who know Java really well, they'll know that we have like these special annotations to describe the columns in the database, the name of the table. In Rust, we are using SQLX. It's not visible here. Actually, it's in another file, but SQLX expects normal types, common types. So not the types that we defined. So not the username type, not the email type, but instead like strings, vectors of bytes, UUIDs, and datetimes. If you need to create your own custom type for SQLX, so SQLX can talk to the database, you need to derive it and create it like so. So here we create a status because our database we have a SQL type that expects a status to look like this. So up next is the meat, sort of. This is the request handlers. So the endpoint files contain the two request handlers. One will create your account, and the other will retrieve it. So let's look at the Java one first. So this is our get mapping to account/ID. It will respond with an account, and this function requires an ID, and we use this annotation to inform it that it comes from here. And voila, we have this repository, which we auto-wired in. This repository contains like the methods that actually that will end up talking to the database. We have one called find by ID. It returns this optional construct. And if we have something present, like if we have an account entity that we got from the database, we will map it to the API type with this mapper that we also auto-wired. So once we map it, voila, we have the account itself, and we just respond with a 200 OK, and the account is there. If nothing is present, we just say not found. So very simple. This is like very standard, nothing fancy. In real life, you will have multiple layers of processing, but here it's just very simple: retrieve, map, do nothing else. So in Rust, it's pretty much the same, just ever so slightly different. Here we have the getAccount method. It will take in a path that is actually a UUID, and it will return an HTTP response or an error. So we have the account repository with a function defined that takes an ID. So this find by ID takes a user ID, but this is just a UUID. So we do this .into to transform it. Of course, this account repository is talking to the database. So that's going to mean you're doing a network call, so you need to await and wait a little bit for a response. And if you get some account, great. You're going to create a response that is a 200 OK. This is going to be a response builder, and you're going to add a JSON body to it. And that body is going to be the account mapped into the API type with this .into. And then this generic type, this specification of a generic type. So this right here is a turbofish for anybody who's ever wondered what the turbofish means. It's this little syntax right here, colon, less than, greater than sign. Basically, JSON is generic over T. It takes a value T. But when you're using it, you need to say what that T is. So here it's account. And here we transform account entity into account using this .into. So voila, easy peasy. If you get nothing back, you just say done. Okay, so awesome. So you guys just saw a bunch of code implemented twice. This was load tested. It wasn't extensively load tested, but just a little bit. And I load tested the following function, or I guess this area right here, creating an account. So creating an account is a bit more involved. We will get the create account. We will validate it. We validate it here. We will do some mapping. We create the the account entity that will go to the database. We set the fields. We send it off to the database, and then we just return by mapping that entity back into the API type. So nothing, I mean, you guys can look at this code, nothing too fancy here. So let's take a look. So this was the meat of your code, but let's take a look at some of the kind of like auxiliary code that you have to write as a web developer. So remember, Spring Boot comes with a lot of fancy stuff. One of the fancy things is it already implements methods to create, delete, modify database entities. So notice how this interface is completely blank, nothing to write. With our Rust land, we're using SQLX. SQLX is not an ORM, and you have to write your own SQL, as you see here in yellow. This one will select and get the account. This one will insert. So this is code that you, as a developer, will have to write if you're doing even the rudimentary of just storing, retrieving, or modifying rows in the database. So this is that. Up next are mapping. So mapping is something that we do a lot in my company, as I mentioned before, and you can easily make mistakes, just like the username and the email are like the same type. So get email. For example, this could be like a mistake that I've more than once have made. This will compile just fine. Over here, we won't, that mistake will not work. Actually, it will, because we're using the dot into, and this knows how to transform itself into a string. So that will work just fine. But anyways, the biggest thing to show here is that mapping is done in Rust using the from traits. So we from an account entity into an account. That's basically code word for map from entity to API. So this is how it's done. Okay, so this is basically all the code I want to show. I want to now talk about the load tests, and I want to show you guys the commands I use to run it in case anybody ever wants to reproduce it. So the load test answers a really easy question. It's, how many requests can this implementation handle? And the request is simple. It's going to deserialize the HTTP payload into some sort of internal type. It will run the validation field that we saw. It will process the fields, run some business logic. In this case, it's going to be hashing a password, generating a salt. It's going to serialize that into some representation that Postgres can talk to. It will wait to get a response from the database and then serialize a JSON HTTP response. So all of this is happening whenever you make a single request. Okay. So the load testing is done with a tool called Goose. It's written in Rust, but it's basically the same as a locust in Python if you ever use that. The way it works is you define the requests and everything you want to do in Rust, and then you run a command to bombard your servers with requests. So that's what I did. I bombarded each one, one after the other. So one would be running in production, bombarded for 10 minutes. I will use 80 total threads, spawning 20 threads per second. And each one will start making HTTP requests to create a user account. And I randomly generate like a username, an email, and a password. So each server is a very affordable server here with 2 gigabytes of RAM. And these are the results. So I ran this a couple times, and I saw that with Actix Web, I was able to get like 5 times the amount created. And probably like so this is exciting, but it's also important to note that you can always tweak it a little bit. So if you increase the number of database connections, for example, you might be able to pull create more requests for both implementations. Also, I maxed out at 80 users because if I went up to 100, my Spring Boot application would start to run out of memory. So this was like 80 was like the safe max I could do, so I can compare both. And if I were to reduce the number of database connections, so each implementation had 4 connections to the database. If I were to reduce those to 1, for example, I would start getting timeouts in Rust with SQLX. I'm not sure why, but I guess 1 is just not enough. So yeah, so that's the results. And I wanted to talk a little bit about some prior work. So Spring and Actix Web are like new things that I learned like when I started learning Java and Rust. But beforehand, I was really familiar with Python, and I wanted to learn other web frameworks in a different programming language. So that's where I discovered this website. It's called the Tech Empower Web Framework Benchmarks, in case you guys have never heard of it. So Tech Empower is a software consultancy. Not sure where they're located, but they publish these really famous benchmarks every year. As you can see, this is 2021, for a multitude of frameworks. So I've clicked filter, and I filtered by Spring Boot and by Spring and Actix. So
can I interrupt?
Sure.
We have a question about that last slide you showed.
Sure.
Is this showing 25K requests per second?
No, it was not. That was per the time, so 10 minutes. It took 10 minutes to do that. So it took 10 minutes to create 25,000 users. Let me go to it. So you have to divide that by, I guess 10 minutes to get like per minute. Any follow-up questions? Or that would be amazing if 2 gigabytes of RAM and 2 like pseudo CPUs can create 25,000, like could do all that, and like that would be really cool. But no, it took a while. But anyways, so back to Tech Empower. So I recommend people going through this and figuring out like basically the different frameworks and like how they compare against each other. So they have a bunch of different, I guess, benchmarks here. So composite scores, Fortunes is probably the most common, is the one I recommend looking at, because this Fortunes is sort of like what a backend web developer, it kind of mimics the code that a backend web dev shop would do. So it exercises ORM, database connectivity. It does like server-side templates, cross-site scripting, countermeasures, and it even like it does some sorting. So all these sort of things are run in this benchmark. So yeah, here are the results of like different things, composite score. But anyways, yeah, this is how I discovered Actix Web is through Tech Empower. And that's how I started learning Rust really is, hey, I want to learn a web framework. Which one should I learn? Oh, Actix Web. What is that written in Rust? So yeah, so that was a comparison of a really fast comparison of Rust and Java. But I wanted to leave you guys with a bit of recommended talks that I personally recommend. So these are talks that I've seen before, not live, but that I've watched before. The first one is John James's Considering Rust talk. So he delves into more technical tidbits about how Rust is doing what it's doing, and how the code, and looking at the Rust code, like snippets of Rust code to explain like what the code actually does and what kind of features it's doing as you type in the code. And the next one is Brian Cantrell, Summer of Rust. So this one is a rather long monologue by Brian Cantrell. He describes sort of like this journey that he took throughout his career to like figure out, I guess what his career has taken him through various like languages and companies and frameworks. And he kind of touches upon like the feel, like what you can taste, like the palatable developer experience of the different languages. He touches upon Java, upon Go, other languages. I think his he talks about his favorite, or at least at the time favorite, and then he talks about Rust, obviously. So this is a really, I highly recommend this talk just because he's very impassioned, and Rust is only like a tiny bit at the very end, but you see this progression of kind of like the feels you get for various languages. So yes, the code that I showed you guys is publicly available in my GitHub, Marzipan Club /Java Rust, and you guys can like check it out and run some load tests. I'll be curious if people can like, if anybody would have like something interesting to report with load testing. The load tests, really fast. So if you clone the repo, you will get a couple directories. The load test, so Java and Rust, the load test is right here. It's a single file. Right here, if I can make this bigger. So you can add more. So this is a single function, create account. You generate some information, do a request. So if anybody is curious and wants to like load test this code or some other code, I recommend, Goose has worked really well. Highly recommend it. But so yeah, that is everything I wanted to present. Does anybody have any questions?
I think we've got a comment here in the chat. If you want to take a look at that.
Sure. Let me just open it up. Okay. Yeah, so the comments is this by Amit. Yeah, so the tech empowers. So regarding the async stack versus async versus sync stack, if you look at tech empower, they have various like configurations. So one of them is using Actix Web with Diesel. Diesel is a Rust ORM instead of using SQLX. So if you look at that comparison of Actix Web and Diesel versus Spring, you will notice that the differences are much minor because Diesel is not asynchronous. So you will see like a less of a stark difference versus what I was showing, which is SQLX.
Yeah. Hello, Jesus, can you hear me?
Yes, I can.
Yeah. So actually, I also did the same comparison in my organization, in my company. I also created one POC. So I use the Spring Boot Web Flux and Actix Web, same thing, but I was using on Cassandra, not on Postgres. Okay. So SQLX does not have Cassandra wrapper. So that's why we didn't use SQL Expert. But yeah, so comparison was the Rust was 4 times better comparatively with the Spring Boot, right? But what I would suggest, what I would do is like, because you have to use both async framework to get more better performance out of Spring Boot.
Yeah.
Because that is much better. Spring Boot 2 is much better with the Webflux rather than.
Yeah, no, I bet. I mean, you have to, if you cared a lot about performance, then you would try to use anything async.
Right.
Yeah, I'm just not familiar with it. Like Tomcat and Spring Boot was basically the setup I use at work. So that's the least.
Yeah. Spring Boot 2 is like the new way which they've developed on Netty. So Netty is better than Tomcat because it's event-driven async framework.
Cool. Okay, good to know. Thank you.
So, yeah.
Yeah, that may be more like a quick insight that I think might be causing that timeout you mentioned. Like, I think I saw that basically in your cargo tunnel, you're using SQLX with the async STD runtime versus the Tokyo runtime, because like SQLX can use both, and it can, I think, yeah, both. I don't know if it supports other ones. But basically, you probably have right now like 2 runtimes running at once, and one of them is handling the like database connections, and the other one is handling web stuff. So it's probably like something that has to do with that, I would think.
Yeah, I think, yeah, I'm not super sure. I would assume that the SQLX would be running on top of Tokyo as well, because the Tokyo executor is what Actix Web is spinning up. And I didn't write any special code to well.
Yeah, basically it's kind of a foot gun with async, because like if you don't, basically each runtime is going to bundle its own networking primitives. So like if you SQLX by default, if you use the async STD runtime, it's going to use the async STD network primitives that are like implicitly going to spawn in async STD runtime.
Yeah. Okay.
It's kind of a thing, honestly.
Yeah, I take back what I said. I need to look more carefully, but good to know. There's another message here. Yeah, so the last message, there was a bit of a debacle between in the Rust community, specific with Actix Web, due to its use of unsafe. So yeah, I can shed a little bit of light on that. So it happened about a year, maybe 2 years ago now. But the issue was that the original maintainer of Actix Web was using a lot of unsafe code. So unsafe code meaning he is when he coded up Actix Web, he has these invariants that he promises will not break. So he's able to insert special code and unsafe blocks in Rust. That gives a lot of like speed and boosts to the web framework. But other like contributors were saying, we should try to like move away from this, because these invariants that you personally like can hold in your head really well, like it's kind of hard for us contributors to like contribute. Why don't you like transition to safe Rust? And the maintainer was completely against that idea. So he ended up stepping down and donating, or I guess opening, giving the torch to somebody else. So Actix Web still is like super popular, and it's used by a lot of companies in production. It's like flourishing, and like version number 4 is about to come out. It's been extensively like beta test for the last like year or so. So it hasn't like died or anything. In fact, it has more competition now, which is good. Another like comment here.
More of a question again. Like, which one did you like working with the most?
Which one? You mean like Actix Web versus Spring?
Yeah, like which of the projects did you like enjoy writing the most?
I will say, so it's not like I have nothing against like both of these, but I will say that I'm more of a incremental learner. So I prefer small like steps when I'm coding things. So this happened a lot when I was learning web development with Python. I preferred using Flask because it's a micro framework and it works like it doesn't include a lot under the sink. Comparing this to Django, Django was like you have to read a lot of documentation to know what the defaults are if you ever want to edit some of those defaults. So the same kind of like process, or I guess the same preference applies here as well. With Spring, it's nice that it includes everything and it has all these defaults, but when I want to change something, I find that I have to go through a lot of documentation just to like figure out how to customize behavior. Versus with Actix Web, I don't have to do that because Actix Web doesn't come with a lot. Everything else is added incrementally by me as a developer, adding more crates. So I would say I prefer Actix Web for that reason. Yeah, that's, yeah, I was gonna say like Rust. I think I like Rust a lot, but that's completely separate.
Okay, do we have any other questions or comments? Going once, going twice. All right. Well, thank you, Jesus, again for presenting at our meetup. If you want, you can also submit a PR to our talks repo and have your talk added there. And without further ado, actually, I'm going to roll into some announcements first before people all start leaving. So for the next several meetups, actually, like into the new year, up to February, we're actually covered. So if you've been paying very close attention, next month we have Bo-Chun presenting, and then the month after that we have Carol Nichols presenting. And if you're not familiar with Carol Nichols, she wrote the Rust programming language, or at least she was a co-author of that, and co-author of like Rust in Motion, and I think there's one other book, I can't remember which one it was. We also have Bastian Gruber, who wrote, I think, something about Rust and web development. I can't remember the title off the top of my head. And Tim McNamara in January, who will be talking a bit probably about his book.
You have like two really prominent names, Carol Nichols and Tim McNamara. So
yeah, those are pretty prominent.
Oh,
yeah. So
you just rated
yeah, it is a lot to take in. So yeah, we have some pretty big names coming to talk at our meetup soon. They're already scheduled in if you've been paying attention to the future meetup events. Oh, we've got another person joining. Sorry about that. And this is because of our partnership with Manning Publications. So big thanks to them for helping out and allowing us to feature talks from these very prominent names in the Rust community. If you stick around, I'll also give you some links and a 35% discount code off of any products on the Manning Publications website. So stay tuned for that. So one thing that I wanted to discuss is about the December meetup, because Bastian Gruber, he lives, I believe, in Germany, or at least in some European time zone. And he can't do our regular 6 p.m. Time slot here. So I kind of talked with him a bit. It sounds more like we might be able to do something at around 1 p.m. our time. But obviously that's kind of in the middle of a work day. I kind of doubt that I would even be able to show up for something like that. So how do people feel about having the December meetup being moved to a weekend?
It works for me.
Yes, for weekend? Okay. Sounds good then. Yeah, I'll float that out there. I might even open up like a poll as well just to get some more opinions. But I really want to ask you all first because you're the people who actually show up for the events, and I really value your opinions. So yeah, the only other thing I have to say is yeah, call for participation. So as usual, we're always looking for more speakers at our meetup. Since we are booked until February, yeah, if you sign up for a talk, it probably won't be happening until the new year, unless someone cancels and we shift things around. But yeah, just be sure to let me know if you're interested in coming and talking at one of our meetups. You can message me on Meetup, or you can send me an email. And yeah, the last thing I wanted to mention here is that some of our speakers are asking me, what do people at these meetups actually, want to hear more about? What kinds of topics do you want people to talk about at our meetup? So if anyone wants to float out some suggestions right now, I'd be happy to collect your feedback, and I can let people know what you guys think. And yeah, that's pretty much it. I'm just gonna move on to the news segment now, and yeah, you can just post whatever ideas you have in the chat, or you can send them to me through private messages. So let's go ahead and share my screen.
Can I make a quick comment?
Sure, go ahead.
Oh yeah, so regarding the speakers, Tim McNamara and Carol Nichols, and like they're really big in the Rust community. So Tim McNamara, like I have his book. If anybody is curious, his Rust in Action book is out, and it's for anybody who wants to like see like snippets of Rust as it will be written in production. So I highly recommend the book. I haven't personally started reading it yet because I am still going through like the Klapnik and Nichols book, so the Rust book. But if anybody is into podcasts, the Virtual World has a podcast featuring Tim McNamara. That's how I found out about him, is through this podcast. Highly recommend people hear it. It's really cool. And it made me want to buy the book immediately after hearing about learning about him through the podcast. So just like a small plug. That's it.
All right, cool. Yeah, they are very big names in the community, so I'm very excited to have them actually coming to our little meetup here. So without further ado, I'm just going to share my screen. I'll hop over to the Pocket as usual. And as usual, I always post these articles that I collect to the meetup events afterwards, so don't worry if you miss these. And let's just get started here. So the first one that I have is about splitting the const generics features. This article is about how the const generics project group plans on splitting out the future work that there will be on const generics. I'm actually very excited about this. Like, this is kind of a big feature. I don't really know as much about the later features here, but yeah, definitely looking forward to like generic const expressions. It's going to be really cool. It's going to get us a lot closer to something like dependent types in other languages like Idris. So that's something I'm really looking forward to coming to Rust. We've also got the Rust 2021 celebration and thanks here. Let's go view the original. So yeah, I think the Rust C edition 2021 is about to arrive, and so they're throwing a big celebration. Yeah, just thought it'd be cool to just show this off in case you want to read it for yourself. In not so happy news, we've got Unity filing a patent for ECS and game engines. So this one may not seem to affect Rust immediately, but yeah, there are a lot of Rust game engines in particular that are using ECS. Like I can name like Amethyst and Bevy off the top of my head as like the major game engines that are using ECS. Now I don't know the extent of the Unity patent, so I don't really know what they can actually lay claim to, but yeah, it doesn't seem like a really great situation around that. Hopefully they don't actually really exercise that patent for anything really nasty, but yeah, we'll see, I guess. Got the new Rust version. Yeah, we got faster, more correct float parsing. They got this error kind variance update. Open range patterns might be useful. And some more stabilized APIs in case you're interested. Usual updates. Oh, and there's also a note about the turbofish syntax. So Anna Heron was a member of the community who coined the term turbofish and has recently passed away. So yeah, rest in peace. Yeah, that kind of sucks, but yeah. Last but not least, we have this rather controversial tweet that I'm sure a lot of you have probably already seen by now. It's Steve Klapnik. He's one of the authors of the Rust programming language, and yeah, he's responding to this article saying, "I refuse to let Amazon define Rust." I think the original article actually got changed at some point because yeah, they did say somewhere in here that Rust's core principles were like based on like Amazonian principles, and that's what triggered this response. And I think they've actually removed that from this article now. So yeah, that was kind of interesting. There's been a lot of discussion about this, talk about maybe trying to get more visibility into what the Rust Foundation is doing and what's happening on that side. So yeah, there's a lot of drama. I'm not really super big into like these kind of drama posts, but I thought it was kind of important to let people know that this is one of the bigger issues that we're probably going to be facing as we move forward as a community, growing. Right, Rust is getting bigger, and there will be growing pains, and this is just one of those. So yeah, that's it for today's news segment. Of course, here we go. We got the Manning Publications partnership. I'll just post this information for you in the chat. Let me just stop sharing my screen, actually. There you go. So if you want to get a 35% discount off of products on the Manning Publication store, you can use that code. There's also this free ebook that they want to promote, a Rust sampler. Again, also that one's authored by I think it was Jake Golding and Carol Nichols, but yeah. So do we have any other questions, comments, feedback? Anything to discuss about the news? Anything you guys want to say? All right. Well, with that then, I will stop the recording and we'll end our meetup. So yeah, thank you all very much for attending today. and hopefully we'll see you all again next month when Bochun presents.
Looking forward to it. Thanks, guys.
Thank you, everyone.
See you.
Have a good night.
Bye.
Thanks a lot.